In this video, we're going to create a very simple pick-and-place application using the teach pendant. So we've got our teach pendant, our robot. We're in manual mode right now, and we've got guard stop. So we need to click the enable button, turn the motors on. In this simple program, we're going to move the robot down to the pickup location. Let's say it's over here somewhere. We're going to do a joint interpolated move down, a linear move down to the pickup location. We're going to move back up with a linear move over to the place location and do the same over there. Obviously we don't have any tooling on here. If we had tooling, we'd want to activate the tooling at the pickup location and at the place location. So to start, click on ABB, click on Program Editor, and because no program exists, it asks if we want to create a new one. In this case, we'll just create a new one. We could also load an existing one and start from there. If a program already exists and you just want to overwrite it, the easiest way to do that is to click on ABB, restart, and instead of just doing a warm restart, click on Advanced and do a P start. This will erase all programs in the system and restart the system. So we're just going to cancel that for now, and I'll close that screen, and we'll close this screen as well. We'll go back again, Program Editor. We want to create a new one, and there we have our new blank program. We have one module, and we have one procedure named main. Remember that every program has to have a procedure named main. That's the entry point for the program. And SMT or statement is highlighted here, so we can start adding instructions as soon as we move the robot into position. So we'll start moving the robot down towards the pickup location. So we are in linear jog mode and we have no increment. And remember, screw the lid on, so we'll go down. And it looks like let's say we're just above the pickup location there. Obviously, when you're doing this with the real robot, it'll take a lot more time than this to move into position. So I'm going to go to the jogging menu. We want to do an align here. So this is one of the few times I have to go into the jogging menu. And we'll start align. And it looks like our robot was already aligned with the axes. And just go back. We can leave the jogging menu open and we can just flip between screens here. So we're waiting for a statement. Let's say that's our first position. So I'm going to add an instruction. We have common instructions here. If I click, then I can see all the different categories of instructions. So I could pick on the motion category, and I've got all the different move commands. But common will have the common move commands that we'll use. So I'm going to use a move J command, a move joint. And we've just inserted in there. We have our position. The data is not shown. We show an asterisk because the position is in line with the command. And to show all that data would be too much data to show on this small screen. We have our velocity. We have our zone. And if I just hide that for a sec, we have our tool that we're using. We don't have any tool defined here. And we'll talk about these. You should also look in the notes to see what these mean. So now we're going to move down to the pickup location. And we're going to make this a linear move now. So move linear, move L. And I want to insert it below the current one. I'm going to move back up. Now what we'd normally do here is if we had a gripper, for example, that we had to actuate, we would probably do a set or a reset to turn one of the outputs on or off. And then we might, go to the next screen here, we might have to do a wait time and give, for example, 0.2 to 0.5 seconds for the gripper to open or close before we start leaving that location. In this case, we're not going to. We're just going to back out a little bit. So we're going to do a linear move away from the point. And then let's go up and over to our place location. So let's assume there's something in the way. We have to go up a fair distance, and we'll come over, and we'll program this intermediate point in. So we'll do a move J to this intermediate point, and then we'll continue on and go and just start approaching Okay, let's say we're just above our place location there. So we can do a move J to that location. Then we're going to move down to the place location. Slowly down. And let's say that's in position for our placement. And we're going to do a linear move there. And then we would set our reset to open the gripper, give it a little bit of wait time to allow the gripper to open. We're going to back off that point. And then we'll do another linear move away. And then let's go back to what we might call a ready position. And we can do a joint interpolated move back to that position. So we've got all our instructions in there now. Our linear moves for pick and placing are moving at 1,000 millimeters per second or 1 meter per second. That's a little bit fast. So if we click on here, we can go and we can select a slower speed. Let's go down to 100. And our zone data, we actually want to find here. We could have done this on the previous screen as well. So let's do the same with this one. So we can change it here, and we just click on the zone data and change it here. Since this one's leaving the point, we don't have to go precisely through the depart point. So maybe we'll do a Z10. And we want to do the same here. So V100. And in this case we want to do a find because we're moving to the final placement point. We want to make sure that we get exactly to that point. And 100. And we'll do a Z10. So that's our program complete now. We're ready to run it. So we've got our motors on. If we try to run right now, we can single step or run. So I'll try a single step. It says start failed. At least one task is missing a program pointer. So there's no program pointer set yet. We have to tell the controller that to set the program pointer to the start of the program. So from within the editing window, we can go to debug and then PP to main, program pointer to main. And now we see the program pointer showing up here, this yellow arrow. And we can program pointer to cursor, to a routine, etc. So we can turn this debug off. And now we can just start stepping through. We do one line at a time. And notice the little indicators here. This is our current program pointer. That's the line that's going to be running next. And this is the current position of our robot, the little robot. So I'll just click run. That looks good. And notice that it continuously runs. So we'll just hit stop. And if we want to change that behavior, click on here and you notice that we've got run mode is on continuous. So we click single cycle instead. Click here again to close that. Should run one cycle, then stop. There we go. We can also run this from the production window, which is where you would run programs in production, so in automatic mode. And here we have PP to main right here. We don't have to click on the debug menu. So PP to main, we're already there. We can see the program pointer, and we can click run. Again, we can single step through or stop, just like we could in the editor window. So now that we've got our program written, let's go back to the program editor. So we can look through, we've got these tasks and programs. We can now save the program as. We don't need to save the system modules. We didn't make any changes to them. So we can click OK. And we can either select a folder on the teach pendant or the flex pendant. Unfortunately, that might be wiped out. You can see here, since I'm using the virtual flex pendant, it's going to store it in a location on my computer. On the flex pendant, you can't store directly to a computer that's connected to the robot from the flex pendant. However, you can insert a USB device, USB storage device, and store to that instead. So you can select drives. If you go up a few folders on the real pendant, the real flex pendant, you can select your USB device and store to it. If you watch a follow-up video on how to edit your program from within Robot Studio on the real robot, then you'll see that you can also access this program immediately without even saving it. You can access it from within Robot Studio, and you can do further edits, and you can save it as well there back to the regular computer.